In example 2, we're told that for some function g, the first derivative function yielded the following critical points. So this should be for a function g, not f. So for g prime of x, we know that that function, that derivative function, is going to take on values of 0 at -8, -1, and 3. What we did in the previous example was then look at values in between. We had to test points in every single interval, so on either side of each 0, to determine what the behavior of the function is. Now, instead, what we're going to do is look at the information the second derivative gives us to classify each of these points, or try to classify each of those critical values as a maximum or a minimum, keeping in mind that the answer might be neither. In part A, we're told that g double prime, so the second derivative of g, evaluated at -8, is equal to 7. Since the second derivative is equal to 7, that means our function is concave up at that point. So we know that the first derivative is equal to 0, our function is concave up, and that tells us that we have a local minimum at x equals -8. That's a much faster process than what we did before, where we had to investigate points on either side of -8. We're told that g double prime of -1, so the second derivative function evaluated at -1 is -10. Since the second derivative is negative, that means our function is concave down. We know that our first derivative function is equal to 0 at -1, and since our function is concave down, we know that we have a local maximum at x equals -1. In part C, we're told that the second derivative function evaluated at 3 is equal to 0. That means this is an inflection point. For our function, so concavity is changing. That means we don't get a clear answer about whether the function is concave up or concave down. So all we can say in this case is that the test is inconclusive, and x equals 3 could be a maximum or a minimum or neither. The key idea is that word inconclusive. If we get the second derivative equal to 0, it tells us no information regarding whether we have a maximum, a minimum, or neither. We'd have to then do some investigation where we check points on either side of 3. So we'd have to see what's happening at x equals 2, what's happening at x equals 4 relative to the first derivative. So additional investigation would be required in order to classify x equals 3 as a maximum, minimum, or neither.